Well, good afternoon or good morning or whatever it is where you are. A good whatever it is to you are good whatever it is where you are to you. John Barba here from Takeo Comfort Solutions, along with Dave Holdorf, and we welcome you to this July edition of Takeo Tuesday, and it's going to be an exciting one because we're going to talk about residential efficiency ratings for circulators. This is something new that you're going to start seeing in the coming months. That'll be on every circulator made, not just Takeo, but this is going to be an industry-wide thing, and we want to be able to tell you what these things mean and what they can do for you and how important they are. So it's going to be kind of an interesting program. I'm going to encourage you guys and gals, men and women out there, to ask your questions. Please make sure you ask your questions. And the first way to do that is to go to your chat section, your questions chat section, and just type in your question. Type in a hi, hello, how are you, just so I know that you guys can hear us okay, and that that you know how to do this, because this is going to be real important. You want to ask a question. Participation is going to be beneficial. It keeps these things going smoothly, and it keeps these things more engaging, because quite frankly, Dave and I, left to our own devices, we're not that interesting. So we need your questions. So the more the better. The more the better. We will stop every few slides and just do a quick review of any questions that are out there. So please please feel free to ask your questions as you think of them, and we'll address them as we go. All right. So that'll be very, very important. Extra sour cream, please. Okay. I'm not sure where you are there, but that's good. Okay.
Taco Tuesday.
Oh, tacos for lunch. Thank you. It took me a minute. It took me a minute. Very good. Very good. But anyway, also the other piece of advice I have for you all is to make sure you have a pad of paper and a pen or a pencil nearby and take notes. Treat this as you would treat a classroom exercise. So take notes as we go along. That'll help you pay attention. It'll help you to stay engaged. And it'll help you when it comes time, if you want to ask a question, you can refer back to your notes. So these are all very important things. Now, this webinar is being recorded, and by noon tomorrow, you'll receive a follow-up email from us with your, just to say thank you for joining us. There'll be your certificate of attendance, as well as a link to view the recording. So that'll all come your way tomorrow automatically. You won't have to do anything extra to be able to view the recording, and you can view the recording as many times as you like. So with that, and with no further ado, what I'd like to do is start our presentation. So I'm going to do the entire world a favor and turn off my webcam so you don't have to look at my ugly mug. And I suggest, even though Dave's a little bit better looking than I am, I suggest Dave do the same so we don't cause any distractions out there. So with that, I just want to get started here. And again, the session today is on efficiency ratings for residential circulators. And these will be on all ECM circulators starting, you should start seeing them sometime in August out there in the marketplace. And this is a mandatory rating system. Now, please don't confuse this for Department of Energy regulations. The DOE, as of January of 2020, instituted efficiency regulations for what we would consider commercial circulators. Anything 1 horsepower and above must meet certain efficiency ratings in order to be manufactured and sold into the marketplace. That did not cover smaller residential circulators, anything under 1 horsepower. The process for making those guidelines is back in place, and I think the earliest we might see anything actually take effect is probably going to be 2, maybe 3 years down the line at a minimum. So none of these ratings are, guidelines, meaning you have to put these in. You cannot put in your standard AC circulator motor. That's not what this is all about. You can put in your standard AC circulators, for the foreseeable future. We do, however, have ECM circulators available, and we have had them for years. This energy labeling, this energy efficiency or energy ratings labeling, is part of the process that's going to work towards that. But what it's really designed to do, as far as the Hydraulics Institute is concerned, and we'll explain to you who they are in a little bit, It's designed to help incentivize the market to start the process of conversion. There are still many states out there, many utility areas out there that offer substantial energy rebates for these things, either to the homeowner or to the installing contractor to be able to install these things. But it's not a mandate as of yet. But we're going to show you what these labels mean and how you can use them as we go along. So let's get started on our presentation. Now, you've all seen these things, right? These things are on all kinds of appliances, both, whether they're home comfort related or not. You see these things everywhere on water heaters, boilers, you name it. These energy guide stickers are on all of these appliances. And what they're designed to do is to estimate your yearly energy cost based on a wide variety of assumptions. But they're basically a guideline for you to compare the relative energy efficiency of different products, of different options. So this water heater might cost $260. The water heater shown here might cost $284. That gives you an idea of which one is more energy efficient. All right, so it's an estimate. And on those appliances, the actual agency that puts those on there or mandates them is the Federal Trade Commission. What we're going to be looking at with circulators doesn't come from the Federal Trade Commission. It actually comes from the Department of Energy by way of the Hydraulics Institute. Or actually, we could reverse that. They come from the Hydraulics Institute by way of the U.S. Department of Energy. So they're similar but different. And what you're going to see on circulators is something that looks kind of like this. It's a Hydraulic Institute energy rating. So it's similar but different. It doesn't give you the dollar amount this thing would cost to operate. It gives you a rating, okay? It gives you a rating that's probably most analogous to either AFUE, which you're familiar with, or SEER, which you're familiar with. So the energy rating comes from the Hydraulics Institute, and we'll explain who they are in a moment. And that's going to be coming this summer. Starting by the end of July, we'll be putting these labels on our circulators, and you'll see them in the marketplace later on in the summer into early fall. So these ratings will cover all circulators under 1 horsepower and below. And you're going to see some two very important numbers. It's this one right here, the CEI, which is the Circulator Efficiency Index, and then ER, the energy rating. In the case of the Circulator Efficiency Index, the lower the number, the better. In terms of the energy rating, the higher the number, the better. And I will tell you right now, 188 with current technology, that's the highest there is out there. 188 there's no circulator out there that's better than 188 in terms of its energy rating. So these numbers are kind of like SEER. What do they mean? What do they represent? How do I quantify it? All of these numbers are in relation to a standard efficiency circulator of similar size. Your basic standard efficiency circulator is your baseline. All these numbers in terms of energy rating will tell you how much more efficient is this circulator compared to a standard efficiency circulator of the same variety, as well as other circulators within the category. Again, all ECM circulators within the category. So let's continue on this because I don't know if it sounds confusing to you at this point or not, but the two biggest things you have to remember, CEI and ER are kind of two ways of saying the same thing. The lower the CEI, the better. The higher the ER, the better. All right. And again, they're kind of like it's kind of the same thing. They're the flip sides of the same coin. Two ways of expressing the same thing. If you really want to focus just on one number, probably best to focus just on the ER. Again, because the higher that rating, the better. This thing right here is a range. Again, we're talking about ECM circulators, they're variable speed, right? So that range of operation is from its most consumptive mode of operation to its most efficient or least consumptive mode of operation. So in this case, that 138 number might represent this particular circulator, our delta T pump, the VT2218, running at its full speed. The 188 would be the circulator running at its most efficient and lowest speed. All right, and if you know anything about delta T circulators, and we'll explain them in a little bit, they're more likely to be running on the higher end of the ER than the lower end of the ER. So again, we will discuss that as well. Again, Dave, do any questions so far out there? Because I know this is a little bit, might be a lot to take in right away. So I just want to make sure we're good on questions, etc.
Well, there was one question that came in from Bill, and he was asking if the ER numbers are theoretical or actual testing, and I know that's coming up in a couple of slides.
That is coming up. That is coming up, and there is extensive testing and auditing of testing that goes into this. So it's really kind of an interesting process that all the manufacturers have to go through in order to get their rating. So it's very interesting. Well, let's start by just giving you an idea of who is the Hydraulic Institute. Who are they? We never heard of them before, but they are the Hydraulic Institute. And what they are is it's an association of all kinds of pump manufacturers. And this group has been in business since 1917. And they are quite literally the global authority on pumps since 1917. And they have many, many jobs. Primarily, it's to develop standards for the pump industry, for pump design, for pump operation, for pump testing, and for manufacturing. So they develop the standards, and what they do is they serve as a liaison between the industry and the Department of Energy. So they work with the Department of Energy to develop these fair regulations. Basically fair so they can be instituted without, crippling the pump industry or without driving costs out of control. So they're kind of a liaison between the industry and the Department of Energy. And they do massive amounts of work in terms of developing standards that all the manufacturers have to adhere to. The program that we're working with for the energy rating is all a part of testing and rulemaking that's been done in conjunction with the Department of Energy. The U.S. Department of Energy says you have to do this. You have to create circulators that meet these certain recommendations, these certain specifications, these certain energy consumption guidelines. This is what we want. From there, the Hydraulics Institute takes over and puts everything into motion. What they do at that point, and this is what happened with the commercial industry, is the Department of Energy said, this is the minimum efficiency we will allow from this point forward. The Hydraulics Institute then said, okay, here's how we're going to do this. Here's how we're going to test it. Here's how we're going to verify it and make it an overall level and fair playing field for everybody involved. So the Hydraulic Institute puts that all into motion. What they do is they approve testing labs. They have a very exhaustive protocol for having a testing lab certified. When you are a certified testing lab, you have to test to the protocols the Hydraulic Institute specifies. And they have guidelines for machinery calibration. They have guidelines for personnel training. They have guidelines for everything, for how you fill out your paperwork. All of that is specified by the Hydraulics Institute. So if you are an approved test lab, which TACO is, you have to follow these guidelines to the letter, and then your test results are then independently audited. So it's not any one particular manufacturer's say so. These numbers that you see, if you test it in this facility, that facility, or that facility, you get the same results. All right, it's not because everything is standardized. It's not that, hey, no one has home field advantage. Let me put it that way. Nobody has home field advantage, and all of the test labs are essentially the same. And then once those results are submitted, they are then audited. The whole process is audited, all of the paperwork is audited, and everything is standardized. So there's no gaming of the system or anything like that. So again, it's a very objective and third-party verification of the performance of the circulator that you're holding in your hands. So with that said, let us continue. All right, so what is the point of all of these energy ratings? Why do we have to have these stickers? Is this just more, government regulation? Well, no, not really. The point of these ratings is threefold. First off, we have independent third-party ratings. This isn't TACO saying so. This isn't any manufacturer saying, here's what we can do. This is an independent third-party verification of the performance of a specific product, of a specific circulator, independent third-party verification of that performance. Now, utilities can use these things. As we mentioned earlier, public utilities are, throughout the country will offer rebates. For example, in certain states, if you put in an ECM circulator of a certain efficiency, you can get a $100 rebate or a $75 rebate, or whatever that rebate might be. In some cases, the contractor who purchases that from a wholesaler will get that rebate at the counter. In other areas, paperwork has to be filled out by potentially the homeowner or the contractor, and then rebates are paid after the fact. It just depends on where you are. What these utilities are doing is they're buying energy efficiency. They are incentivizing you to install more energy efficient products. Not so much that it's going to impact the homeowner's electric bill, although it will to a degree, but more importantly, we have more stuff in our houses these days that use electricity than we've ever had before, right? What they're trying to do is lower the overall load on the energy grid, just for sustainability. So utilities will use these ratings to determine incentive levels and their rebates, etc. For the trade, it gives you a very useful tool to demonstrate savings over standard circulators. And we're going to walk you through the math on that in a little bit, but this is kind of important. It's, people in non-utility or non-rebate states, have been slower to adopt ECM technology because of the cost. These things are more expensive. What's the value? They do save some energy. It's not enough to change anybody's life in terms of, oh my God, my electric bill is going to be cut in half. Doesn't quite work that way because we're not talking about, big motors here. But what this does demonstrate to the trade and to potentially the trade's customers, the homeowners, the end users, is that the whatever additional cost there is for an ECM circulator over a standard circulator is going to be offset by the electrical savings, in some cases in less than 2 heating seasons. So in that case, the point there is the homeowner has bought that circulator. They're paying for that circulator anyway. It's just a matter of whether they get it or not. So in some cases, less than a year and a half, that circulator's electrical savings will offset whatever additional cost there is to buy it. All right. And at that point, everything else beyond that is gravy. So that's one of the key uses of these labels. All right. And then lastly, it also is an indicator of who's offering the best technology. And the TACO circulators we're going to show you at the very end are the top rated circulators in the industry. None of the major manufacturers have come close to what our circulators are capable of doing. So what is the point? Here's a really good look at the point. And this is a direct quote from the Hydraulics Institute. Circulator energy rating labels are only applied to the most efficient circulator pumps on the market. Rated circulators save energy, maximize overall system efficiency, cut operations costs, and reduce carbon emissions. That's why they're putting them on there. That's why they're putting them on there. How you use these labels is going to be, again, the point of the rest of the presentation, but you'll see how they can be to your benefit. All righty, so what are these labels? This is an actual look at the label that you'll see on the circulator itself, okay? And what it does is it compares ECM circulators to baseline pumps. And what that rating is, it's actually a percentage of it's a percentage. It indicates a percentage power savings over a traditional circulator. Now, this example circulator of the label we show here, model ABC123, has a energy rating range of 150 to 180. That means it'll save up to 150 to 180%, use 150 to 180% less energy than a standard efficiency circulator over its life. So that's what those numbers actually represent. And again, the CEI, the Circulator Energy Index, is another way to compare that consumption. Again, there are two sides to the same coin, so to speak. So here's the story, all right, some basic information. So if we take a look right here under number 1, this comes from, again, the Hydraulics Institute. First off, you get your basic information. You get the pump brand and model. So in this case, we're looking at the Taco VT2218. Okay, the weighted average input power, this number here, WAPE, weighted average input power in horsepower for an ECM circulator without controls. So this is basically gives you how much energy does it consume uncontrolled or at its maximum speed. It's kind of a weird number, but what it's designed to do is it helps us convert horsepower to watts. All right. One of the things we want to do is the Hydraulic Institute, the Department of Energy deals in horsepower. When we're dealing with fractional horsepower circulators, like these little less than one horsepower deals, when we're dealing with fractional horsepower circulators, we're more concerned about watts. So we've got to convert horsepower to watts, and WAPE is what helps us do that, as you will see. It's a weird number because it's basically it's the weighted average input power in horsepower for the circulator without controls, which they don't operate without controls, but that's kind of the logic behind it. Next, we have the Circulator Energy Index. That's the CEI. All right, and that's the rating index comparing power consumption to the traditional circulators. Lower is better. And energy rating, again, kind of the same things. It's a way to indicate the percent power savings over traditional circulators. In this case, the bigger the number, the better. All right. Section 4 down here tells us available controls. So the VT2218 being a delta T circulator, it could either work at full speed. You can set it up to be a full speed, fixed speed pump if you wanted, or you could let it run in its delta T mode, meaning it'll vary its speed to maintain a specific temperature difference within the system, which is its most efficient operating mode. All right, and then lastly, we have estimated savings. Down here, this is the math formula that we're going to use in a little bit to tell you how to convert this number along with the WAPE to convert that into estimated energy savings, estimated cost savings. So you can illustrate the cost savings. You know, this is going to use $35 less energy annually than a standard efficiency circulator, or $45 or whatever it might be. So again, WAPE, that's important to note. It's the weighted average input power at full speed. So it's a conversion factor, so we can turn horsepower into watts. And again, CEI and ER, as we said before, it's two ways of saying the same thing. And then we talk about controls, all right? And then the potential savings. So that's how you would read that label, okay? So how do we use this? Now I'm going to look at a different circulator here, the Taco 0015E3, which is a 3-setting delta P variable speed circulator. And its energy rating is 152 in its most consumptive mode to 188 in its least consumptive mode. All right, so we look at that. We see our ER is 188, the CEI is 0.39. All right, it's a 44-watt pump, so it's a little bit, it's a lower wattage consumption than say at full speed compared to the VT2218. But here we have our different operating modes. All right, we have full speed, or we have pressure. It's a delta P circulator, meaning it changes its speed to maintain a specific pressure differential within the system. All right. So how would we use this information? Well, first off, let's compare a Taco 0015E3 to a standard 3-speed circulator, which is really what we're trying to compare it to. All right, compare the Taco 0015E3 to any standard 3-speed circulator, but it's the standard efficiency Taco 0015, whether it's the Grundfos 1558, the BNG or NRF 22, take your pick. All right, to actually calculate out, all right, our energy savings, presuming we install this thing properly in its most efficient mode, we set it up in its most efficient mode. We start out, let's take a look right here. It says power savings watts over a baseline case can be estimated by multiplying the ER, that's the energy rating, okay, we'll look at this number, by the WAPE, all right, that's this number up here, 0.071 for this particular circulator, and then multiplying by 7.46. That helps us convert horsepower to watts, okay? And then we turn that into kilowatts, and then we multiply, and we figure out how many hours we anticipate this circulator might run, and then we can figure out how much it will cost, how much energy it will save in dollars and cents over the course of a heating season.
Hey,
So
John?
let's start. Yes,
John,
sir.
we got a quick question that came in, more referencing the slide before, but also we can apply it to this slide.
Alrighty.
So this circulator, the 15E3 is showing an ER of 188. The question that came in is ER 188, is it 88% higher efficiency than the standard or 188?
It'll be 188.
Okay, percent more efficient.
Right.
188% more efficient. Okay.
Right.
Yep.
Right. Because your standard efficiency circulator is going to be a 0 on this rating. Everything is based upon that particular pump. So let's figure out our math here. So we're going to presume we're setting up our circulator at its most efficient point, all right, which is very easy to do. If you size the circulator properly, you know the flow, you know the head, you can set it up so it'll work in its most efficient manner. So 188 times the WAPE of 0.071 times 7.46 gives us 99.57 watts. That's over, that's how many watts it will save over the course of a heating season. Well, we got to turn watts into kilowatts and then figure out kilowatt hours. So to turn watts into kilowatts, we divide by 1,000, all right? And that'll give us, we'll call it 0.099 kilowatts, okay? 0.099 kilowatts is a fair number. Divide that by 1,000, that's what you get. Next, we want to multiply that by an estimated amount of runtime. How many hours over the course of a heating season do we anticipate this circulator to operate? Now we can look up, the Gas Appliance Manufacturers Association publishes a map that gives you an estimated amount of hours in different parts of the country we expect heating equipment to operate. If you go to the mid-Atlantic area, it's around 2,000 hours. You start, let's say, in New England and move to the upper Midwest and down into the Rockies, you might be at 2,500 hours. You move further north, it might be 3,000 hours. It doesn't tell us how cold it is. It just tells us how many hours there are in the run. It gives you the breadth of the heating season, not necessarily the depth. Your heat loss and all that will tell you the depth. This will tell you the breadth of the heating season. For our purposes, we're going to use 2,500 hours. If you want to use 3,000, you can. It's just a matter of comparing apples to apples. So if you think your circulator, if it's a zone valve circulator, you think it might be running longer than 2,500 hours, you can certainly use 3,000. Absolutely. In this case, we're using 2,500 hours. So 0.099 kilowatts times 2,500 hours. Well, that's 247.5 kilowatt hours. Once you have your kilowatt hours, now you simply multiply it by your cost per kilowatt. All right. In our example, we're going to use 15 cents a kilowatt hour, which is a slightly high national average. So 247.5 kilowatt hours times 15 cents per kilowatt hour. This is giving us an estimated savings over the standard efficiency circulator of a little over 37 bucks. So over a 7-month heating season, this is going to cost $37 less to operate. All right. There's a bunch of other benefits to using a variable speed circulator beyond the electrical savings. But what this is allowing us to do is it's allowing us to put an independent third-party number on that electrical savings. We'll talk about the additional benefits later, and the additional benefits, in my opinion, far outweigh the $37.13. But this is an illustration of that upfront cost discussion. So $37.13 annually at 15 cents a kilowatt hour, that's how much less it's going to cost per heating season to run compared to your standard efficiency 3-speed.
Okay,
How
hey,
do we
John,
use? Yes, sir.
I just also want to point out, now those of you that have been to some of the ECM classes with John and myself, you've seen us do this math before to show you how much it would cost over the course of a heating season. So very similar math when you start looking at those last 2 lines, or
Right.
last 3 lines, okay? This is the savings, not what it would cost you. So
Exactly.
this is the savings comparing the one to the other. I just wanted to make sure everybody knew that that, when you see those formulas, you've seen us do it before, just so you know, this is the difference between the two of them.
Exactly.
And a couple other questions came in. One came in from Paul, was asking about, the 2,500 hours, is this relative to degree days? And that number we have, we got from AHRI, and they had given us numbers across the country in average runtime in hours. To cross over to get it into degree days and do the math from there would have been a whole nother class all by itself. So we use this chart instead that we got from AHRI a few years ago. That gives us average runtime across the country, and 2,500 is right about where Rhode Island is. So we figured we use the Rhode Island numbers there. So
yeah, Rhode Island into Massachusetts, southern New Hampshire, and they just move west across that bar, and you'll find that it's about 2,500 hours. And again, the number is going to vary based on where you are and what type of a system that you have. I mean, can an argument be made as well, if we have everything on outdoor reset, will the pumps run longer? Potentially, maybe. Again, if you want to use 3,000, you certainly can. You certainly can. But 2,500 has been a pretty good number for our purposes. Already.
Another question came in, John, was, so here we're comparing it to a standard circulator. So what is that baseline for a standard circulator, and who decided its details? Was the question.
That's a really good question, and that is something the Hydraulics Institute said when they figured the baseline. The baseline was a comparable circulator in that same category that's kind of the industry standard in AC. So in this example, we're talking about, more than likely, again, the Taco 0015 or the Grundfos 1558, something in that 80 to 90 watt category. So it would be a circulator of similar performance in the AC market.
And something else about the Hydraulics Institute too is, yes, there's a bunch of people that work there, but there are also those of us at the manufacturers that also assist in there too.
Right.
As in, and we're not there to help push this along or force it down everybody's throat. We're also there and sitting side by side with the competition, and all just to make sure it gets done properly, and it's not just some crazy stuff that comes out of nowhere that everybody has to adhere to. So it's actually this has been stuff that's been going on for since I started here at Take almost 9 years ago. These conversations have been going on. Now it's just coming to fruition in getting these labels and ratings and stuff like that. So,
right, like I said earlier, the Hydraulics Institute's been the global spokesman for the pump industry since 1917. So that's a long time. And manufacturers are, all the manufacturers are members of this. We all have a seat at the table. So there's no, this is one company's organization while another company prefers this organization. It's the organization, and they level the playing field. And so we're all playing by the same set of rules, and we're all being tested to the same standards against the exact same stuff. So it's about as independent and third party as you can get in terms of just straightforward, non-biased information, which is what makes it very useful and pretty cool, actually.
Yeah, another question came in. Do we have something written with these formulas that are here? And actually, it's nothing on our site that we have just yet, but you can get to the HI website, which we'll show you right at the very end, that you can go and download all the data you like there. So excellent. Thank you for that question, Gordon.
Yeah, we'll show you a website, the Hydraulics Institute website, where you can look up any pump that you want from the major manufacturers and compare and see, here's this pump, how does this pump there? What's the numbers on this pump? Let's go look at this pump and compare and contrast. So you can see those, look all those up to your heart's content, and we'll show you that at the very end. So terrific.
Yep. Another question came in from Walter, and he was asking about in residential, the use may be different from that projected. How can we, compensate for that? Well, I think the only way that you can do it is a couple of ways. One, you have to know exactly what the runtime is of your circulators, and we can get that, say with the 0018E, which we'll show you next time. Or put data loggers on, and organize it that way. So that's where some of those numbers came from already. Yes, it's an estimate. You know, in
Yeah.
my house, do my circulators run longer than 2,500 hours? Heck yeah, because I'm modulating the world, right? So I'm modulating water temperature, modulating the boilers. You know, I'm doing so much modulation on my circulators will probably run a little bit longer than somebody with a cast iron boiler that's 3 times its size, and way oversized in element in the house, where it's going to fire for 45 seconds and say, all right, I got more than enough.
Right.
So
And
everybody's
again,
different. They're averages here.
and again, yeah, these are averages. They're comparative tools as opposed to 100% accurate predictors. All right. This will give you an idea of in a normal winter what we can reasonably expect. Okay. And then how do you use that? Well, there's a bunch of different ways. Probably the most simplest way is to show that, hey, this is going to represent a pretty quick offset of price. So compare, I just looked these prices up online. You wanted to buy a Takeo 0015 or a 1558. I looked at one online supplier. They're about $100. All right. If you were to look up the same thing and buy a Takeo 0015 E3, it's about 147, 150 bucks, depending on where you look online. I'm not saying these are what they should cost. This is what we were able to find. And if you look at that, okay, I saved 37 bucks compared to the standard. 50 bucks more, I can make a pretty reasonable case that the electrical savings will offset any change than 1.5 heating seasons. So here's the point. Is this more expensive by maybe 50% than a standard efficiency pump? Yeah, but they're going to buy it anyway, right? They're going to pay for that pump.
Okay. Well, it sounds like John is having some technical difficulties at the moment. Hopefully everything is all good. I'm still here, so hopefully can you still hear me? Dave Holdorf here. I just want to make sure that you guys can still hear me out there. Excellent. Thank you, Greg. So as John was saying, and we'll see as he comes along, and if I got to change the presentation over to me, I will do that. So what he was saying at the end there was, and these are just approximate costs. He was just finding some general numbers around it. Prices may be different in your town compared to somebody else's. So it's going to, 1.5 heating seasons just based upon the electrical savings is how we're going to offset those costs in that circulator. So yes, you're going to spend more for that circulator up front, but then in 1.5 seasons, then you're at your break-even point, so to speak. All right, and we try not to talk about, installing a high efficiency circulator that's going to be a return on investment, because there is no such thing. Return on investment is if the circulator went out and got a job, all right, and then it paid you to heat your house. So we know that doesn't happen. You just want to be able to use the least amount of electricity there. So so let me, John, if you're still on, no, I don't know if John is on. So let me pull over the presentation. Hang on 1 second, everybody, and we will finish this up. I will be right there. 1 second there. And John, I'm sure, is frantically trying to get over here too at the same time. All right, 1 sec. John happens to be away at the moment, and I think he lost connection completely. So now I've got back, and here we go. Awesome. All right, and I got you back. All right, let me move my screens around. And this is where he left off, as we saw before, between the 1558 and the 0015 standard AC circulators compared to your 0015 E3. Okay, so with that being said, now what if we would have, JB, what's happening?
I am back. I'm sitting, just so everybody knows, I'm sitting at a Westin hotel in Greenville, South Carolina, and the Westin lost its internet there for a couple of seconds. So I apologize for that. Thank you for picking it up and running with it, Dave. That's great.
Not a problem. I just sent it on back to you.
All right. And I'm going to show my screen. Can everybody see that?
We got it.
All right, hang on a second. All right, thank you, man. That's all good stuff. All right. So we talked about, where did we leave off? Right here, about the quick offset, correct? So
Yep.
yeah, your
Yep.
offset is less than 1.5 heating seasons in this example. Now let's take a look at, as Dave was preparing to talk about, the delta P versus the delta T differentiation. One of the things you're going to see is the U.S. Department of Energy has classified delta T as the most efficient way to run a variable speed circulator. All right, and it's not particularly close. It's a level up from your delta P. So this is a very important different point of differentiation when you're talking about delta P versus delta T. Now, most residential ECM circulators are delta P, meaning they vary their speed in order to maintain a particular pressure differential within the system if they're set in the constant pressure mode, which is the right setup for most North American systems. Why are most residential ECM circulators delta P? Primarily cost. They are less expensive than the delta T options. And just that the technology is a little simpler and they don't do quite as much. All right. But according to the Department of Energy, delta T does offer the greatest level of electrical efficiency. And they also, as we have, if you've been on any of our presentations in the past, you know that maintaining a nice, delta T in a system, the delta T that the system was designed for, will bring the lowest possible water temps back to the boiler, which has a tremendous impact on boiler short cycling. And if it's a modulating condensing boiler, it also ensures that the boiler is going to have the greatest opportunity to condense in most any situation. You're not intentionally shrinking the delta T as the loads get lower, as the temperatures outdoors get warmer. So that improves the boiler efficiency and system efficiency as well. So you're getting a double dip. The only thing the Hydraulics Institute is going to look at is the electrical efficiency part of the equation. It doesn't look at the other part of the equation, but that other part of the equation is substantial. So let's take a look. In terms of just qualifying delta T performance, this picture that you're looking at here is published by the DOE, and it gives us levels of overall efficiency based on based upon the inherent efficiency of the motor itself. And it has levels from 0 to 4, and it's every half of a point or half a degree. So your single speed induction motor, that's your standard efficiency motor, your basic circulator, baseline efficiency is rated as 0. Next up is if they improve the best efficiency point in any case, we can get as high as 0.5 to 1 to 1.5, depending upon, or up to 1 rather, and depending upon the motor. As we work with ECM or electronically commutated motors, you can see how they move up in levels of efficiency. So let's take a gander here. At the this chart was published by the Department of Energy, and it's their Appliance Standards and Rulemaking Federal Advisory Committee, better known as ASRAC. Remember that. That's going to be on the final exam, gang. All right. And this was published way back in 2016 because they studied all of these things. And here you see 2.5 to 3. That's pretty much the peak efficiency level that you're going to get from a delta P circulator. All right, because we're talking about proportional pressure. If you take a look at the lines here, let's take a look. You're talking about automatic controls, proportional pressure. Now, proportional pressure, if you were to look at a pump performance curve, proportional pressure looks like that, meaning as flow goes down, the head pressure differential created by the circulator also goes down, and the electrical consumption goes down because the speed will go down. That's a great performance curve for residential circulators. That's a great performance curve if you have continuous circulation with thermostatic radiator valves that kind of modulate. All right, that's really the best place to use proportional pressure because that's the peak efficiency of a delta P circulator. In terms of performance for for your standard North American system, whether it's a zone pump or a zone valve system, is going to be something like this, which is constant pressure, meaning we maintain a fixed pressure differential in the system. That tends to work best with zone valve applications and then obviously zone pumping situations. So this 2.5 to 3 is if we're in that proportional pressure mode. Right around 1.5 to 2 is going to be maybe more of your constant pressure setup, potentially. It depends on how it is set up. Now, if we take a look down at the bottom with our automatic controls temperature differential, we're dealing with much better efficiency levels. So we're talking about 3.5 to 4. So it's much more efficient to vary the speed of a circulator based on temperature differential, because not only does it react to, let's say, zone valves opening and closing, it will also react to changes in outdoor temperature. As it gets warmer out, the pump will run slower because we don't need to yank as many BTUs out of the water. Even if we have outdoor reset, they don't fight one another. They work beautifully together. This is all cool, but what the heck does it mean? How do you interpret that? This is government talk I'm going to share with you now. This is government talk. And they're talking about alternate ELs, okay, efficiency levels, results and comparisons. So when we're talking, and here you see these numbers represent efficiency levels, okay, and quads. When we're talking about quads, it's quadrillions of a unit of fuel. So what we're talking about here, the takeaway here is, forgetting all the mumbo jumbo, the takeaway here is a delta T, level 4 delta T will save the most energy over its lifetime. If you compare it to a delta P circulator at level 3, it's going to save over its lifetime nearly 20% more energy over the lifetime of that circulator. And how do we know that? It's going to be right here. It's in terms of quads. Okay, 1.15 compared to 0.93. Well, what's a quad? A quad is 1 quadrillion BTUs. Okay, it's equal to 1 quadrillion BTUs. So if we switched all circulators from delta P to delta T, if we switched all circulators from delta P to delta T, according to the US Department of Energy, that would be equal to saving 1.761 billion gallons of gasoline. That would be the equivalent in terms of energy savings. Okay, I don't know how to quantify that other than, yeah, delta P is going to be your more electrically efficient solution, and it's also going to work better with your boilers. Enough said. Now, let's put this into terms we can understand on a micro level. That's the macro level. Let's look at it at a micro level. At a micro level, let's look at what a VT2218 can do versus a standard efficiency 3-speed. So we have our WAPE right here. We have our most efficient mode right there. So 188 times 0.077 times 7.46, that's 108 watts. We turn it into kilowatts. We turn it into kilowatt hours. All right, 15 cents a kilowatt hour. Now we're talking about 40 bucks compared to your standard. So it's $40 compared to your standard, $40 less to operate than your standard efficiency circulator. Now, if you were to go out and buy a VT2218 online, you might find a price right around this number. It's a more expensive circulator. It's a better circulator. It's a more expensive circulator, $256. What does that mean? Well, if we're working on it in terms of offset compared to $100 circulators, that offset will take place in less than 4 heating seasons. We'll have that offset in place in less than 4 heating seasons. And on top of that, we are also, because of the way the delta T circulator works, on top of that, we will also be forcing that boiler to work in its most efficient manner for as much of the time as possible. We will avoid that incredible shrinking delta T, which again, if you've been to any of our presentations before, we know, because as an industry, we overpump, man. We'll get the boiler to work more effectively. We'll get the boiler to work more efficiently. We will reduce wear and tear on all of the moving parts in the boiler because we're not short cycling nearly as much. So the boiler is going to be more efficient. And in terms of straight line electricity, that circulator's cost is going to be offset in less than 4 heating seasons. So, any questions out there, Dave?
Rich was just holy cow based upon the quadrillions over there.
Yeah, that's a lot.
It was a
That's
lot.
a lot of quadrillions, man.
So I think we almost made Rich speechless at the moment.
Wow. Now that's an accomplishment. That's an accomplishment. Now the product labeling. Here's where you're going to see the product labeling. The product labeling will be appear on the box for the Takeo circulators. You'll see it right there. It'll appear on the box, and then the label on the circulator itself. For us, it's going to be right on the bottom, right there. So it'll be on the here. You see a sticker on the side. That's a UL sticker. The energy rating sticker is going to be on the bottom right here, as well as on the box. So it'll be permanently affixed. Now, again, we told you our circulators were top rated, and the results kind of speak for themselves. We had the 5 top rated circulators in the industry, and none of the other major manufacturers kind of came close. All right, we outdistanced our nearest competitor, nearest major competitor, by at least 6% on their most efficient circulator. We have 5 circulators that were more efficient than that, which is not to brag, but that's pretty impressive. That is pretty impressive. So in terms of specifics, we have the 0018E, which is a multi-feature, multi-function circulator. It can be set up in delta P. It's a delta P circulator, but it can be set up in constant pressure, proportional pressure, or fixed speed. We can adjust it just to be a fixed speed circulator. And the 0018E is also the Bluetooth circulator that we have that connects to an app that allows you to really fine tune it. So that energy rating range from 168 to 187. Okay, our VT2218, the Delta T circulator, all right, is 152 to I'm sorry, I got all these mixed up here. I'm sorry. This is the 008. This is the 0018. All right, sorry. The 007E is this circulator. All right, that's a single setting circulator. You just put it in and it works off of, it's a variable speed circulator, but works off of a single performance curve. Okay, the 0015E3 is this guy right here. All right, again, 3 settings, low, medium, and high, constant pressure settings. That's 152 to 188. And then we have the VT2218. That's that guy right there, a Delta T pump, which works from 138 if it was full speed, fixed speed, all the way up to 188. So as you can see, we have 1, 2, 3 circulators that have the highest efficiency in the industry. Nobody tops 188 with today's technology. Moving forward, we have 2 other circulators that were top rated. The VR1816, which is basically your 0018E without Bluetooth. That also is 152 to 188, so that gives us 4 circulators rated at 188. And then in terms of circulators made specifically for domestic hot water recirculation, the 006E3, all right, the highest rated domestic hot water specific circulator in the industry as well. Now, all of our other 00s, the 007E, the 15E3, and the 0018E are also available in stainless steel models with the same efficiencies. So there's a little bit of a difference there, but for a specific domestic hot water only circulator, the 006E3 is the highest rated in the industry, ranging from 162 to 174 in terms of its energy rating. All righty. Now, I'm going to show you where to look these numbers up yourself and write this down. This is the website. It's er.pump.org. er.pump.org. And again, if you want to look these up for yourself, that's the website. And I'm going to take you there right now really quickly. Okay.
So one comment came in from Gordon earlier, and he was saying, so basically there really is no reason to use anything else but an ECM circulator. And Gordon, if I could, I'd get up and give you a big old hug right about now.
So, there you go. That's right.
You know, so yeah, that's what John and I have been trying to preach over the last couple of years, that the only reason to not use an ECM circulator has been cost. You know, And they've got a track record behind them. And those of you that maybe you're not that familiar with them yet, don't worry, you're not going to get serial number 001. We've been making them now for almost 20 years. So they've been out for a really, really long time. Yes, there's different models that get introduced all the time as the industry is changing, but they've been around a while now. So don't be afraid of them.
And just a little background on ECM. ECM stands for electronically commutated motor, and that technology goes back to 1969. General Electric first came out with an electronically commutated motor over 50 years ago. If you put in furnaces, variable speed ECM fan motors have been in use for years and years and years. On the circulator level, the first ECM variable speed circulators came out 1999-2000 in Europe. A company called Ascol was the first to introduce that to the marketplace in Europe. The circulator division of Ascol was actually purchased by Taco about 6 years ago. So now they're known as Taco Italia. All of the circulators you saw here that we just showed you, those are all made by Taco in Cranston, Rhode Island. So those are all American-made circulators based upon that platform, but those are all American-made circulators. And the VT2218 has been around it started out as the Bumblebee, if you remember that. Now the VT2218 is like Bumblebee 2.0, and that is also made in Cranston, Rhode Island, and that is a North American specific product made for the North American market. So I want to show you this real quick. This is the homepage, er.pumps.org, er.pumps.org. All right, and you can look at a lot of different things here, but the thing you want to look at most importantly is this thing right here. It says search pumps. Okay, search pumps. Click on search pumps, and that'll take you to this search page. And there's two different tabs here that you're going to want to know to differentiate. It says C&I, that's commercial and industrial pumps. Commercial and industrial pumps. We don't want to look at that. We're looking at circulator pumps right here. So we go to circulator pumps, and you can put in a rating ID, a basic model number, or you can go down here to participating organizations, and you see Armstrong, Xylem, Taco, Grundfos, and you can pick whichever manufacturer you want and look up their products. So we look up Taco, all right, and it's going to be search for rated pumps. You click on that, and what will come up is all of the circulators that we have rated. We have other manufacturers will have their circulators have different models of the same circulator listed because they have different flange configurations. For us, we have 4-way flanges, so they kind of go both ways. So we don't need to have multiple configurations, just the one standard configuration. So you see the VR1816, and what this will give you, control methods. It's full speed, manual control, or pressure control. It'll give you the energy rating and the PEI. And you go down to 0015, 0018, 007E, etc. So let's take a look at the 0015. If you click on, you see how you move your cursor, you'll highlight a row. Let's click on the 0015, and that brings up the overall energy rating. And it gives you, again, the circulator energy index, the energy rating, gives you the model, the manufacturer's model number, which is a part number, a little bit different. And then you get into the rated control method. In this case, it was constant pressure. All right, it's the constant pressure mode. Those are the operating modes it has. It gives you your flow and head in terms of best efficiency, and the approved laboratory, which is our own laboratory. Our laboratory is HI approved, and they audit everything we do. All right, and the data was listed. All these started coming in April. Control methods. Then it gets into a lot of input power under full speed, input power under pressure control, etc. And then down at the bottom, you see the full energy label. All right, and that's where you will find this particular label with the ratings, etc. So you can go through that and look up any circulator from any of those 4 manufacturers that are that are major or less than major manufacturers, and you can see and you can compare them to one another, but also understand this is all compared to your standard efficiency comp, if you will. So, and if we want to go back and take a look at another one. All right, we go back, we pick Taco. Oh, actually, we got to refresh because let's go back and pick Taco. search for rated pumps. We'll go all the way down to the bottom here, and we'll find the, a bunch of new ones just came up too. That's terrific. So you see, once we get to VR15, all of these are larger circulators, getting up to that 1 horsepower level. But let's take a look at the VT2218, which overall in terms of PEI and energy ratings and WAPE, it's the highest rated circulator there is. And you can see kind of what you'll find here in terms of your best efficiency points, etc. So just wanted to show you where to find that, and then again, feel free to kind of look through that on your own and see what it does for you. And most importantly, the point here was how to use that math, how to use that number, so you can understand the differences. And if your customer has a hesitation, in many cases they really don't. If your customer does have a bit of hesitation, you can show them that they're going to buy this circulator anyway, man. That's the point. They're buying this circulator anyway. It's just a matter of whether they own it or not. And if I'm paying for something, I just as soon own it. I don't know about you. And it kind of makes whatever misgivings they may have go away. I tend to think the misgivings are more on the our level than the homeowner's level. But again, this is just a very valuable tool that you've been given to show if they're concerned, hey, tell them they don't have to be. They really don't have to be. How are we doing for questions out there, Dave?
I think everything was good, man. We were rolling along with them, so nothing. We did have one question about being used with solar panels, and yeah, a lot of our stainless ones can be. It depends if you have an open or a closed unit. Obviously, make sure you know your flow and head before you choose which one you need. So definitely. One just popped in from Bill, and he's like, if I understand this correctly, the ER number is derived theoretically dependent upon what options there are on each pump.
I've gone through the math on how they figure out those numbers, and I'll be very, very honest. The more squiggly numbers there are in a math formula that represent things that I don't understand, I'm going to presume, okay, as long as somebody knows where it comes from, I'm good with it. Is it a theoretical number? Well, yeah, I guess it has to be, but it's as close to a real world theoretical number as you're going to get. Again, I would not necessarily use these numbers to predict how much something's going to cost to run. It's mostly a comparison between standard. You use it as a kind of instead of a ballpark comparison, which you can do just using estimated watts. What this does, instead of it being a ballpark comparison, we can actually get you into the section of the stadium your seat is in, and maybe even into the row. We might not get you to the exact seat in terms of a comparison, but we get you in the ballpark, in the right section where your seat is, and probably the right row. That might be the best way to look at it. You want an exact, there's no such thing as an exact predictor of how much something's going to cost to run, because there's so many other variables, right? If that thing should be set to low and you set it to medium for the 0015E3, all right, the prediction's going to be off a little bit. It still might be better than putting a 3-speed pump in contractor no callback mode, which is definitely going to be better, but that fudges the numbers a little bit in terms of actual application. That's why no matter what circulator you use, it is important to know how to calculate flow and head. Because these things, other than the VT2218, ladies and gentlemen, none of these circulators size themselves, okay? None of these circulators size themselves. I don't care how many times you push the magic button. That's not what that magic button does. The VT2218 is as close as we have to a circulator in this industry that will size itself, because it's based on the delta T at which the system has been designed. That will get you as close as you can get to a self-sizing circulator as there is in this industry, which is great for a replacement circulator, etc. But there's no such thing as push the magic button and it'll figure it out for itself. That's a bunch of hooey. You still have to know how to size a circulator and how to set up a circulator if you're using one of the Delta P circulators made by anybody, not just our own, but anybody. You still have to know that. That doesn't change that part of the equation. Cool.
So I just wanted to reiterate, Bill was asking about no actual lab test is being done. No, actually,
That's where these numbers come from, man.
Yeah. So our facility is an approved lab with HI. So they came in and audited our lab and our R&D area of the company itself, where we can give them that data.
Yeah,
So
and they specify how the test is done. So no, I want to make sure you understand this, Bill. This is a lab. These tests are done in a laboratory, and they are done to a specific set of guidelines. So everybody tests to the same number. Now, does that mean you put that out in the field, you're going to get the exact same number? Highly unlikely, but you got to have something to compare it to, right? It's like, how do you know a 12 SEER AC unit is a 12 SEER AC unit? Because the label says so. The label, you have to have confidence in the label that the testing was done that way. AFUE, it says 84% AFUE. How do I know that? Well, it was done in a lab. I take that boiler and I put it in a building. If that boiler is 4 times the size it should be, it may have an 84% AFUE, but it's not going to be a terribly efficient boiler. So the point is, yes, these are absolutely lab tests done in a laboratory to a standardized protocol. Hydraulics Institute writes the protocol, they certify the labs, they tell everybody, here's the process. Your machinery has to be calibrated like this. Your people have to be trained to these levels. All right. They watch every step of the process. And then when we give them the test results, they go over it a second time. Okay. So I absolutely, these are lab tests. Absolutely, these are tests done in a lab. In terms of real world results, yeah, think of it. How about this? Maybe think about it as this: the mileage for your car. All right. EPA says, well, it's great. The mileage on this car, it's 24 highway, 24 city, 28 highway. Okay. How does that translate to real world? Your results may differ. Okay. But it's how you compare car A to car B. I know if this one has EPA 24 miles per gallon city, 28 miles per gallon highway, and this other car has 30 miles per gallon city, 36 miles per gallon highway, I know that car's more energy efficient. That car's more fuel efficient. Now, am I going to get 36 miles per gallon? I don't know. Depends on how I drive. The way I drive, probably not. I hope that answers your question, Bill, because that's a good question. Here's a question from Simeon. If you say delta T is more efficient, why is the ER only as high as the delta P pumps? I presume ER is strictly on the equipment rating, not in use. I think what you want to do is math that out, including the WAPE. If you include the WAPE, the weighted average input power, all right, you'll find that if you were to do the math, well, we just did the math. You saw a delta P pump at 188 with its WAPE saved like $36 compared to standard. The delta T pump with its WAPE, which was a higher WAPE, I guess, if you will, that model done the exact same math at 188 saved over $40. Okay, by comparison. So that's the electrical efficiency difference when you put that WAPE thing in. Again, in terms of electrical efficiency, if you math it out based on those protocols, then yeah, you're going to say the delta T circulator is more electrically efficient. And in actuality, in actual operation, it's going to be, and that's not us saying it, that's the United States Department of Energy saying it, because it is a higher level, 3.5 and 4 in energy levels as we went through. And that's the Department of Energy saying that, because it is a more efficient way to run a pump overall. Delta T is based on the temperature difference of the water going out and the water coming back. What influences what influences how much energy is being taken out of the water as it goes through a heating system? Well, how cold it is, right? How cold it is and how many zones are calling at a given point in time. Delta T is the only circulator that will vary its speed based on how cold it is, as well as how many zones are open and closed at that same time. That's what the Department of Energy is saying. Okay, so I want to make sure you understand that. That's not us saying that. That's the United States Department of Energy saying that. Okay. Very good. I hope that answers your question, Simeon. Again, really good question. All right, very good. BT2218, we call it putting an automatic transmission on a boiler, says Paul. I love it. That's a great reference, Paul. Excellent. Okay, terrific, terrific. Yeah, and Richard McGrath makes a very good point there. Don't confuse electrical efficiency with system efficiency, because the other thing that none of this stuff takes into account is how each individual circulator affects system efficiency. Okay, because you can put in a VT2218, but if you set it up to run full speed, fixed speed all the time, you're kind of missing the point. It'll be electrically efficient, relatively speaking, to a standard 3-speed pump set to high speed, our contractor no callback mode, but we're missing out on not only the electrical efficiency of the circulator speeding up and slowing down, but also it's not going to be a delta T pump at that point. It's a fixed speed pump. We're not going to get the advantage of having a meaningful impact on short cycling of the system and the boiler, and meaningful impact of the lowest possible water temperatures going back to the boiler, which again, in the case of a mod con boiler, is going to help it con more often, help it to condense most of the time. So yeah, excellent point, Richard. All right, cool, great. Hey, this has been awesome, gang. I hope you guys have enjoyed it. And again, any more questions, please type them in now, because we really do appreciate the gift of your time today, folks. It was an excellent session, even though the Westin Hotel here in Greenville, South Carolina, decided to cut out on me at a given point, right in the high point, right when we were getting to the cool stuff, right? But
Right
Dave,
yep.
Dave is like the great assist. He's the great assist man. He just picked up the ball and ran with it. I love it. So I want to know, at what point did I drop out, and how long was I talking to myself?
It could have been for a while. Yeah, I'm not sure. It was
for a while.
it was starting to get a little cutting in and out there, and I'm like, uh-oh, I better get prepped up here. Let me start the PowerPoint. Let me get it there running in the background just in case you disappear. So, yep.
Good. Hey, I appreciate it, man. That's good stuff. That's good stuff.
Yep. So I also want to make sure everybody knows that next week we are switching over Taco Tuesday to the commercial focus, where Rich and Brett will be in charge and running the show there, and they have the class set up to how to properly size an expansion tank, and they're going to go over Boyle's law, the different types of expansion tanks, pre-charge and ASME pressure rated vessels, things like that. So that is going to be next Tuesday, commercial focus. So you will not see John and I, you will see Rich and Brett, which will do a great job, of course. And I believe even Brett was joining us today too. So thanks for coming today, Brett. I saw you hanging in the background there.
Oh, excellent, excellent, good, Brett. And then and the following week, we'll be back to do a deep dive into the 007E, the 0015E3, the 0018E, and especially the VT2218. So you'll really get a good idea of what those things are all about and how they work and where you can make the best use of them. So that'll be an awesome session. We're looking forward to doing that for you as well. So with that, we'll say thank you all for a wonderful midday session. We really enjoyed it. I hope you guys did as well. And again, be on the lookout for that email tomorrow. And with that, we'll say so long from South Carolina, so long from Long Island, and we will see you all we'll see you all next week, and hopefully in 2 weeks as well. Take care, everybody.
Enjoy, y'all.